Hello everyone. In this video, let's talk about how we divide rational numbers, how we divide two fractions. I'd also like to explain why this rule makes sense, where this comes from. So on the screen, I have the rule. It says if a over b and c over d are rational numbers, then a over b, the first fraction, divided by c over d, the second one, that's going to be the same as a over b times d over c. So in other words, whatever fraction we're dividing by, in this case it's the fraction c over d, we can change that to multiplying by the reciprocal. And then after we change it, this is just like the multiplication problems we've done before. And that's the part I want to explain. So why do we change it to multiplying by the reciprocal? So to explain that, let's take a look. We'll keep it general, so we'll keep using variables. But one thing we need to know before we can explain this is exactly what a reciprocal is. So two fractions are reciprocals when we flip one of them. So we switch the numerator and the denominator. So c over d and d over c, these are reciprocals to each other. What that means is when I multiply them together, I end up with the result of 1. And even though we have variables here, we can see that this is going to simplify. We have a c in the numerator, a c in the denominator, that will simplify to 1. We have a d in the numerator and a d in the denominator, and those will also simplify to 1. So anytime you multiply two reciprocals, we end up with 1. So now let's take our division problem, and instead of writing it with our division sign, I want to write this as a complex fraction. So what we're doing is we're going to take a over b, and we're dividing this by c over d. Now written like this, it's very messy and not exactly easy to work with. So maybe I want to rewrite it in such a way that we can handle a little better. So if I want to simplify this denominator, what I can do is I can multiply by the reciprocal. Because if I do that, I know my result will be 1. So in the denominator, I want to multiply this by the fraction d over c. Now when I multiply these two together, I know I'll get 1. But I can't just multiply the denominator by this. I need to multiply the numerator as well, since whatever I do to one of them, I have to do to the other. Now together, these two things, d over c and d over c, this entire piece in blue, this is also equivalent to 1. So in the denominator, this all simplifies to 1. So we end up with, so we have 1 in the denominator. And then in the numerator, we have a over b times d over c. And this is what we have up here. That's where our rule comes from. So now let's use this rule to do an example. So let's take a look at negative 3 over 5. And then let's divide that by the fraction 7 over 10. So the first step, we're going to take that second fraction and we're going to change this into multiplying by the reciprocal. So the first one stays the same, negative 3 over 5. And now our second fraction, 7 over 10, we change it to multiplication and we change it to the reciprocal. And now we can multiply. So when we multiply two fractions together, we multiply the two numerators and we multiply the two denominators. So negative 3 times 10, we have negative 30. And in the denominator, 5 times 7, we get 35. And just like we've done before, the last thing we need to do is simplify this fraction. So 30 and 35, those both have a common factor of 5 in them. So I can divide that out. So if I divide 5 out of 30, we end up with negative 6. And if I divide 5 out of 35, we get 7. So here's our final answer. So dividing rational numbers, dividing two fractions, it's very similar to multiplying. We just have one extra step. We take that second fraction, whichever one we're dividing by, and then we're going to change that to multiplying by the reciprocal. Thanks.